Here's problem number 31 from section 3.1. We're asked to use one-sided derivatives in order to prove that this function doesn't have a derivative. Let's remember that the definition of the left-sided derivative is that it's the limit as h approaches 0 from the left-hand side of f of x plus h minus f of x all over h. And let's also recall here that x equals 1. So therefore we have something like the limit as h approaches 0 from the left-hand side of f of 1 plus h minus f of 1 all over h. Now, quick discussion. F of 1 in this piecewise function is going to be defined using the top expression because 1 is equal to 1. And so f of 1 is equal to 1 squared plus 1, or 2. So this next step becomes the limit as h approaches 0 from the negative side. We need f of 1 plus h, which means we're going to go, when we're approaching 0 from the left-hand side, that means this is going to be f of 1, but just with a value inside here that's below 1. So we're going to be using that first definition again. 1 plus h squared plus 1 plus h minus 2, again because f of 1 is equal to 2, all over h. Now let's see what we get next. The limit as h approaches 0 from the negative side of 1 plus 2h plus h squared plus 1 plus h minus 2 all over h. Now I see a 1 and another 1 and a negative 2. They'll net out to a 0, giving me the limit as h approaches 0 from the negative side of h squared plus 3h all over h. Now that top has a common h in both terms, giving me h times h plus 3 over h, and those h's cancel, leaving me h plus 3 as h goes to 0, which is equal to 3. Great. Now what about the right-sided derivative? Well, that's going to be the limit as h approaches 0 from the positive side of f of 1 plus h minus f of 1 over h. Now, when we're trying to evaluate this expression, f of 1 plus h, and h is approaching 0 and is positive, that means we're going to be using this other definition here. So the limit as h approaches 0 from the positive side of 3 times 1 plus h minus 2 minus f of 1, but we already found out f of 1 is 2, all over h. So this is h approaches 0 of 3 plus 3h minus 2 minus 2. And I think we can just collapse that into a minus 4 all over h, or the limit as h approaches 0 from the positive side of 3h minus 1 over h. Now, I'm not going to waste any time trying to do a algebraic manipulation of that expression because actually let's take a look at the graph of that as h gets closer to 0. So I'm going to go ahead and I'll put in a fraction and say 3. Now instead of h, I'm going to say x. Oops, where's the 3? 3x minus 1, and we'll divide that by x. And if you look at that graph, you're going to see that this expression, as h approaches 0 from the positive side, is negative infinity. Let me bring that expression back up. Yep, it goes to negative infinity as we get closer and closer to 0. Now, that being the case, that means that these two limits don't agree. That means that the overall limit, the limit as h approaches 0 of f of x plus h, let me be more particular here, 1 plus h minus f of 1 over h does not exist. And if it doesn't exist, that means the derivative doesn't exist. And there's problem number 31.